This is M7, and as always with the mechanisms, just make sure to write in a notebook the different ones like 1, 2, 3 through 5, and then of course this is the final one. This is going to be the hardest one, but it's actually not too bad. All we're going to do is leave this hydrogen by itself by creating a double bond from this oxygen to carbon. Hit arrange. So the end product is you have the hydrogen by itself, the water molecule, and then you have this 7-member ring with the oxygen that has 2 lone pairs, and another oxygen with 2 lone pairs double bonded to the carbon. Okay, the first intermediate, and then most of these are just gonna contain one move. I think only the second one has 2. So for this one, we're gonna wanna attach this hydrogen molecule, and we'll use this double bonded oxygen over here. I'll go ahead and grab it, hit arrange, and we're gonna go ahead and leave that double bond because that's what we'll be using for the second intermediate. And then for all the cyclic pi electrons, we're going to go ahead and put 0. So the fourth intermediate, you kind of just look at what's out of place. So I see that this hydrogen here is kind of on its own. So I'm going to go ahead and attach it to one of these. It doesn't matter which one you use. You can use either one because it's the exact same molecule attached to the carbon. So I'll just go ahead and use this one. And I'll attach the hydrogen. So then eventually in the fifth intermediate is when we'll detach this water molecule that we can see that is forming. And this is the one we'll be leaving. But for the most part, this is the fourth intermediate. Each oxygen has a different amount of hydrogens. So this oxygen has no hydrogens, this one has 1 hydrogen, and this one has 2 hydrogens. And as always, just keep an eye on the electrons and the lone pairs. So I'm moving it around so you can kind of see the different, how many lone pairs are on each oxygen. And for the fifth intermediate, like I was saying, this water molecule we were getting ready to detach. So we'll go ahead and do that. So everything's one move. If you wanted to, you could do a double bond here with the oxygen, but you can also leave it. I've done it both ways and either way works, but I want to do one move only to save time. So I'm just going to leave it, this carbon with 3 bonds only. And we're going to put 0 throughout the whole lesson. And the third intermediate. Okay. So the third intermediate is, if you're writing down the different ones, this is the second intermediate. So we saw the third intermediate when we did the fourth one, and that's when the hydrogen was by itself. So I'm going to go ahead and detach and bring the electrons back to oxygen. So now this hydrogen's alone, and it's ready to get paired up with this oxygen. But for the third intermediate, we're going to leave it just as is. So we have 2 oxygens with 2 hydrogens, and then this oxygen only has 2 lone pairs. Okay, and the second intermediate is the only one that has 2 moves. So the first move will be detaching this bond and bringing those electrons back to oxygen. And now we see carbon has 3 bonds only. So I'm going to go ahead and take one of these bonds and bring it to that carbon. So for this one, you just leave the molecule straight like this, like going from left to right, and it'll be easier to see. And then you can press arrange, and you'll see that that 7-member ring is forming. And we've got those 2 oxygens attached to this carbon, and then the oxygen is now attached and makes up the 7-member ring. Each oxygen only has 1 hydrogen for the second intermediate. And this one only has 1 lone pair. The rest, these 2, have 2 lone pairs. And you can also see they have, I guess, like 4 bonds total. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And yeah, that's it. So for that one, it's not too bad. Just make sure to write in your notebook the different intermediates. Yeah, I think that's what really helped me, just writing down the intermediates and not overcomplicating. I know the final I was kind of overcomplicating when I did it the first time. But yeah, good luck.